really see the layers, kind of got to get as smooth a surface as possible. Here's my little kit. Fingers at all. Go to one finger, and then after that it becomes pencil and knife. And if you can't push a knife into it, it's ice. And what we want to do is see if we can find some layers here, and you can do that by running something down it. So this is all pretty soft stuff. There's no wind crust to this at all. Actually, I might be lying. Yeah, there's a little wind crust, a little change in density on the surface, just from wind action. And that's probably a difference between, you know, and it can be the same resistance. It's still 4-finger, but you'll feel a few centimetres of slightly stiffer snow, less fluffy. You can see it's that stuff there. Okay, so we'll mark that with it's too soft. And feeling down with a card, there's another change in here. This is obviously stiffer snow, so here we've got a fist, and here there's resistance to my fist. So it's 4-finger down here, and that changeover. Yeah, so mark that.
Is that just natural compaction?
Yeah, snow falling under different humidity, different types of crystals, a bit more wind will pack it in, and the weight of new snow on top. Coming down here, still got resistance. Another one there. Coming up from underneath.
Higher.
Yeah, on walking tracks. Yeah. Yep, see the crown walls that run down. See layer in here, like a little crust that's been put down in the storm.
Yeah.
And usually these come in as rime crusts. Riming is where there's more moisture in the air than there is particles to crystallise around. And so you end up with the moisture going straight from moisture vapour to a nice solid when it hits something, even if it's the ground. So there seems to be a little crust in here. It seems to be quite big. We'll see if we can have a look at that. Get more detail. Brush. Nice brush. There we go. Start taking that layer out. Another layer in there. And what have we found here? Almost resistant 4-finger. Don't bend my fingers, so 1 finger beneath that crust. Older, a few days older. It's a real thin one. So there's during the storm cycle, you know, the pattern has changed. It's a really thin one, the top one. Too much brush and blows it away. And then after that, down to the old snow. So there's an old snow interface just there. So all of this is storm snow.
From Sunday?
Yep.
Wow.
Okay, and so and we've got lots of different layers, and what decides the stability of a snowpack is how well different layers are bonded to each other. And as a rule of thumb, what you want to avoid is having very hard layers next to very soft layers, or sandwich between soft layers. So this one here is quite soft, and we've got a hard crusty layer just here, and quite soft again, and there's another mini layer in here. It's quite hard to, a little rime crust. And then this is all kind of one finger, and then we've got this thicker crust in here. This crust here actually is probably, you remember how it rained a little bit after the first storm?
Yeah.
That might be down here as well, so obviously there's been kind of, this one looks much more like a rain crust, which you probably won't see at altitude. And then in here it's back to forefinger, and then change the density back to fist. So when they talk about density changes in the new snow, you know, obviously a bit more wind has packed this, but less wind, it's fallen lighter. When they talk about crystal changes, they're talking about these little ice crusts that exist, or rain crusts. So the crystal is no longer stellar. If you look at the surface even now, you can see still stellar crystals without the aid of a magnifying glass. And as it gets broken up by wind and compaction, it becomes decomposing fragments. And then if you get a bit of moisture into it, it becomes wet grains. Otherwise it slowly bonds up into, on its journey to ice, into round grains. Or if it's super cold, it can change into faceted crystals. We haven't really seen anything super weak in here. Nothing's kind of falling out each layer as we get there. So none of the crystals themselves are poorly bonded to each other. It's just how they're bonded in each layer. Well, that kind of makes sense.